Imagine a world where, with the intake of a single pill, one can have all their medical issues go away. Thanks to the DNA-based molecular programming, the world is now one step closer to experiencing such a phenomenon. Before we dive into how this new innovation works, let's first establish common ground regarding DNA. The main purpose for DNA is to store all information and instructions that basically run a human body. Within DNA, a substance called antibody, which is also an essential part to the DNA computer, helps the immune system fight against external foreign factors, such as infections or toxins, as described by Dr. Ananya Mandal from News Medical. DNA computers use antibodies, as mentioned in our original research article conducted by professors at the Eidvahen University, by translating them into a unique DNA strand that is used as an input for the DNA program. What this means is that since antibodies have the ability to recognize harmful things that don't belong in the body, DNA computers can use that same information to block out undesired systems. Another important concept that should be defined are the DNA circuits or signals, which is the way that DNA sends a signal to a cell so that it can change a particular way. This aspect of the DNA gives opportunity for DNA computers to manipulate cells within the body by mimicking those circuit patterns. Additionally, in the original research experiment, it was discussed that DNA-based circuits were used to process multiple antibody inputs using predetermined logic operations, which will shortly be explored in more detail. DNA circuits are also the reason why DNA-based computers were created. There were limits to their application in synthetic biology, biomedicine, and molecular diagnostics. Let's now get into how this new innovation works. First, it must be noted that DNA computers mimic the natural structure of DNA. For instance, DNA, as previously mentioned, works by sending signals to cells in order to get them to change or to follow a particular form. The same concept is also used for the DNA computers, but for things that are known as logic gates. These logic gates allow for the transformation of different inputs into a predictable output. According to Leah Cannon from the MIT Review Journal, researchers have managed to encode long text into DNA, while others have used molecule to create simple logic gates and circuits, the basic building blocks of computing. To further explain this process, here is a clip from Damien Woods, a computer science professor at Maynooth University.
A molecular computer works by self-assembly. So small strands of DNA stick together in order to grow a larger object. And as each strand attaches, it executes a small part of the computation, a little logic gate, like an AND gate or an OR gate. And so just like you have electricity flowing through a circuit to execute a computation, here in our system, the attaching of DNA strands to make a larger and larger object execute the computation.
In order to make these logic gates function just like a computer, researchers found a way to make DNA computers have the simple on or off function that regular computers have. This is done through a process called strand displacement, which essentially is the DNA's way of copying information over to another strand. Although strand displacement is a very necessary process for the innovation, we will not get into too much detail due to the length of this podcast and the complexity of the topic. This on or off feature is what can potentially create a revolution in the medical field. For instance, as it will be discussed at the ending of the podcast, DNA computers can help create pills that can decide whether or not to deliver medicine to the body. Therefore, the Boolean feature, or this on or off function, is crucial to the whole innovation. The actual programming language used for DNA computers also uses a different programming language from a typical computer. In an article by Martine Amos posted at Encyclopedia Britannica, information is represented using 4-character genetic alphabet: adenine, guanine, cytosine, and thymine, which is completely different from the language than the standard binary numbers, ones and zeros, used for regular computers. In fact, Microsoft has been developing a language called DNA Strand Displacement Tool that can be used to design the DNA sequences needed to run circuits and can model how the reactions will occur in each circuit. There is no doubt that DNA computers have a tremendous amount of potential. According to Eindhoven University of Technology, researchers hope to be able to create drug delivery mechanisms. Essentially, DNA computers will be able to decide with the detection of the presence of antibodies whether drug delivery to the body will be necessary. The source even proclaims that with these drug delivery innovations, researchers might be able to prevent side effects and reduce costs in the future. In other words, DNA-based molecular computers can pave the road for new medical innovations that can help the world.